In this video, we're going to look at implementing the comparable interface in a class that we've written. So I have here a pretty simple student class. We have a first name, a last name as strings, and an integer student ID. Pretty straightforward class. I just have a constructor, getters and setters. The setters make sure that the setter makes sure that the new ID is within a valid range, uses a constant to do that. I have an overridden toString method, which just prints out the last name, first name, and student ID. And then I've also overridden the equals method, which just compares students based on their student ID. I, of course, could also compare them based on ID, first name, and last name, if that makes sense. But perhaps I've decided that I'm only going to compare for equality based on ID. You'd have to think about what makes sense for your class. So this is a pretty simple little class. This is kind of all the basic building blocks that we would have in any class that we write before we go on and add any class-specific functionality, right? We've got our variables, constructor, getter, setter, toString, and equals. So those are basic building blocks. One additional thing you always want to think about is, do you need to implement comparable? So even if you don't necessarily immediately see a need for it, it's often a good idea to implement comparable in classes like this, in classes that represent real-world objects. And the reason for that is that it's very, very common to want to sort real-world objects. If you can think about gathering data, generating data, or presenting data, a very common thing to do is to sort it, right? So if you need to be able to sort data, you have to define how to sort, and to do that, you define how to compare two objects of a particular type. And to do that, we implement comparable in that class. So anytime you need to sort something, that something has to define how to compare itself to other objects of that type, okay? So let's look at what would happen if we didn't implement comparable. So right now I'm going to leave the student class as it is, and I'm going to go over here to a little tester program. And I've just created an array of student objects, and I've got 5 students that I've put in the array, and I'm just going to print it out. Okay, I've just got a little helper method there to print one on each line. Okay, so pretty simple little program. I just create some students and print them out. And obviously they're in the order that I put them into the array. Now, what if I wanted to sort this array? Well, recall that we have 2 sorting methods provided to us in the Java Standard Library. There's arrays.sort, allows us a static method that allows us to sort an array, and collections.sort allows us to sort a list. Okay, so we're using an array. So let's say, all right, well, I'll do arrays.sort. My student array. All right, and no problem, no compiler error. Okay, great. So I can get a compiler error, I'll go ahead and run, but when I run it, I'll get a crash. I get a runtime error. It crashes with a class cast exception. So you will be allowed to invoke a sorting method like arrays.sort or collections.sort on a class that doesn't implement comparable, but you won't be able to actually run it. And essentially what Java is telling us here is that, okay, I'm trying to sort this array of students, but I don't know how to compare 2 students to each other. Like, what makes Sally studier greater than or less than Alan asks a lot? I have no idea. There's no natural ordering of students, so I don't know how to sort this collection of students. So in order to have a natural ordering, the designers of the student class have to provide that. And to do that, we implement comparable. So again, implementing comparable is how you define the natural ordering for any given class. So let's do that now. So let's go back to student, and again, we're going to implement comparable. And I'm not just going to implement just comparable. I'm going to use the generics to say implement comparable and put student in the angle brackets. Because essentially what I'm saying is I'm not going to define how to compare a student to just any object. I'm only going to define how to compare a student to other students. And that logically makes sense. This is the best practice for implementing comparable. There are ways to do it without using the generics, but it's not as clean, it's not as logically consistent with what's going on, and it's not recommended as best practice. So please do use the generics when implementing comparable. Now, as soon as I put that implements comparable, I of course get a compiler error because I haven't written the method from the interface, the compare to method. So let's go down here, and we're going to write the compare to method. Public int compare to. So that is the beginning of the method header. The return type is int. We return either a negative number, 0, or a positive number. The parameter type, because I use that generics, is allowed to be type student. If I hadn't used generics, this would have to be type object, and I would have to cast it just like I did in equals. And then if it wasn't the proper type, I'd have to throw an exception. So it's a little bit more complex and not as clean. And again, using the generics is definitely the best practice recommended way. So please do that. So my parameter type is going to be student or whatever class you're writing in. And my return type is int. Now I'm going to again use the @override annotation. This annotation is always optional. It's never required, but I recommend always using it anytime you are overriding a method inherited from a parent class or implementing a method inherited from taken from an interface. Now, when we are overriding methods inherited from a parent class, the annotation is really helpful because it prevents us from making mistakes in the method header. For example, if I go back to equals and I put the wrong parameter type in here, this override will tell me that by giving me a compiler error at that method header. It'll say, hey, there's no equals method that takes a student parameter that can be overridden. There's something wrong here. So that's the real benefit of using it in inheritance. Whereas without that, I wouldn't pick up on that error at compile time. I'd have to track it down and figure it out myself. Okay, so that's the real benefit of using it for inherited methods. For methods you're implementing from the compiler, from an interface, it's not, you don't get that same benefit because let's say, for example, I made a spelling error or something in my method header here and I didn't have override. Well, I'm still going to get a compiler error because I haven't implemented that method from the comparable interface. So I'll always get caught up on that at compile time. I'll always be told about that at compile time, whether I use override or not. So you don't get that nice benefit with interfaces. It's just, you don't need it for that. But I still recommend using it because I think it's a nice visual cue to a reader that, hey, this is a method that I'm not just writing myself, but I'm actually implementing it from an interface somewhere else. And maybe with compare to, that's pretty obvious because it's a common method, but there might be other methods you're implementing in an interface that someone might not realize, oh, this method is associated with that interface rather than just being, some method as part of the class. So I always recommend it as best practice to use both when implementing methods from an interface and for methods that you're overriding from a parent class. So I recommend it as just getting into the habit of using that. Okay, so now let's look about actually comparing the elements of the student class. So we're going to look at a couple different ways to compare students, and we're going to start by just ordering and comparing students based on their ID. So we're just going to, we're to sort a collection of students, we want them sorted by ID. So to do that, we need to use the compare to method to define how to compare one student, the current student, in our class here it would be this, to another student, the student passed in by the parameter. That's all compare to does. It just tells you how to compare one student to another student. Then that method is used behind the scenes to sort things. But remember, the compare to method doesn't actually do any sorting. It doesn't have anything to do with an array or a list or anything like that. It just defines how to compare one object to another object. So if we want to, the first approach we're going to look at is comparing by ID. Now, student ID is an integer, so I can't invoke any methods on student ID because it's a primitive. So I can't invoke any methods on a primitive. So there's two different ways to compare primitive values. The first way is by using a traditional conditional statement. So I can say, okay, well, if this student ID is less than the other student ID, that means that this student, come on Eclipse, cooperate, is less than the other student. So I'm going to return some negative number. Now, it doesn't matter what number I return, right? Remember, you are never guaranteed any information about what the value is that's returned. So you should never assume that compare to is going to return -1, 0, or 1. Lots of times it does, but not always. So if you're using the return value from compare to, you only ever want to check, is it negative, positive, or 0? When you're writing your own compare to, you can choose. So perhaps you'd want to return the difference between these two values to give some meaningful information in the return value. Or perhaps not. You just want to give a negative number. If you do that, it can be any negative number. It could be negative 127. It doesn't matter. The idea this just has to be any negative number that indicates that this current student is smaller than this other student. Okay. Otherwise, if this student ID is greater than other student ID, that means that this student is greater than the other student. So we want to return some positive number. Again, this can be any positive number. It doesn't have to be 1. probably makes sense in this case to make these parallel to each other. So if I did do negative 127, I'd probably want to do positive 127. But again, there's no requirement for that. I get to choose any negative or positive number that I want. And then, of course, our last case is that the student IDs are equal. And in an else like this, I like to indicate what that condition represents with a comment. And of course, this means that this student is equal to another student. And there, I'm going to return 0. So I don't have any choice there. It's got to be 0. So this will allow me to define how one student should be compared to another student. Essentially, I'm just saying they're compared by student ID. So let's now go back over to our tester, and we're going to print out the array. And then we're going to sort, and then we'll print the array again. Second, let me fix this display. Okay, so note that here we have, remember the order that it first was created in, and then we'll sort using our compare to. So originally we have our array holds, Sally, Pete, Alan, Greta, Uma, and after sorting, you can see that it's sorted by ID, 16, 12, 36, 5289, and the order has been changed. So we've been allowed to sort. If we were to have a list instead of a array, so here we can create a list from our array, we would then use collections.sort, and we'd get the same effect. Okay, so let's not sort it as an array, but instead we'll sort it as a list, and the same thing's going to happen. We'll get the same sorted order. Okay, so behind the scenes, the arrays.sort and the collections.sort and any other sorting algorithm that you might use, any sorting method that you might invoke, it's going to use this compare to method. It's going to go into the whatever type of object is held in that array or held in that list. It's going to go into that object's class, find the compare to method, and that's how it's going to sort things. It's going to use that compare to method to compare pairs of objects using whichever sorting algorithm is being implemented. Now, we're not talking about specific sorting algorithms right now. We're just talking about how to compare two specific objects to each other, and we're realizing that that knowledge is necessary to be able to sort. How you sort is a whole separate topic. Different ways to sort is a whole separate topic, and that's not what we're talking about at the moment. Right now, we're just talking about the fact that in order to do any sorting at all, you got to have some way to compare two objects, and that's what compare to does. Okay, so let's look at another way to compare just by ID. Now, I had mentioned that we can't invoke any methods on student ID because it's a primitive, and that is true. But there is a nice static method provided to us in the capital I integer class, which is the wrapper class for ints, that allows us to compare things. And that allows me to write just a single statement, return integer dot, the method is compare, and I can compare the two numbers. So integer.compare is a static method in the capital I integer class, and it just allows you to send in two integers, and this will return a negative number if the first is smaller, a positive number if the first is greater, and a 0 otherwise. Okay, so it essentially does the exact same thing we just did with our conditional, it just does it in a single sentence. I would recommend using this method anytime you have a method provided to you that accomplishes something. It's good to use it rather than to rewrite that code yourself. Now, if you wanted to specify a specific return value, if you wanted that return value to give some information, then you couldn't use this. You'd have to write it yourself because we don't know what value is returned here. We're not guaranteed of anything about that. We're just guaranteed that it's negative, positive, or 0. So if you want to return a specific value, you would have to use this first approach. But otherwise, you can just use this nice little single line for your compare to. So we can now go back into our tester, and same thing as we just saw, the list is still sorted by student ID. Now, let's look at how we'd sort by something else. So let's try comparing by student name. So we'll try another way. I'm just going to comment all these out so they're there in the file for your reference. And now let's say, okay, I don't actually want to sort by name. I want to sort by, by ID, but I want to sort by name. So name is a string, string's an object, so we are allowed to invoke a method on a string, and we can actually use that to our advantage. So just like a lot of times when you implement an equals method, you'll find yourself invoking equals on your instance data variables. That same thing happens in compare to. A lot of times when you are writing a compare to, you will invoke compare to on your instance data variables. So when you're comparing by some object, your method might be as simple as saying, well, let's just return this dot last name dot compare to other dot last name. Essentially, I'm just comparing by name. And that's it, right? So I'm saying, how do I order two students? Well, I order them by their last names. Now, how do I order last name? Well, last name is of type string. So to figure that out, I'd have to look at the compare to in the string class, which is already written for me. I don't know what that comparison is, but I trust that string has implemented it in a good way. Okay, so let's go back to our tester now and run it. And now you can see that this list is now sorted by last name, AGPSU. Okay. So that's a really good thing. And that's what's really nice about this compare to method and this approach of using the comparable interface, is that it's very straightforward as to how you define the natural ordering of objects, and that you get to choose as the designer of this class what that natural ordering should be. What's also nice is that the class that uses your class, in this case like a driver or a client or a tester program, a class that will sort those objects, might not have any idea how they're being compared to each other, and it doesn't have to know. This is kind of the idea about object-oriented programming, that every object is sort of in charge of its own information, in charge of its own functionality. So arrays.sort or collection.sort says, hey, I don't know how students should be ordered and compared to each other, but the student class knows that, so I'm just going to use that, and then I'm going to sort based on that. And if somebody changes that comparison characteristic like we just did, I'm going to use the new one, right? It's going to use whatever the current compare to method is. And it doesn't have to know what it is. It just has to know that compare to is going to return negative, positive, or zero, and that information can then be used to sort. Okay, so far we've only looked at implementing compare to by comparing a single characteristic. But what if we had a match of a characteristic? So what if we had two students whose last name was Graduate? So we have Greta Graduate, and let's say we also, her brother Greg Graduate is in the program too. Give him a different ID. Okay, so now we have two with the same last name, both last name of Graduate. Well, when we compare the last names, they're going to be equal, so that is going to return a 0. So that's going to say that these students are equal as well. But perhaps we don't want these students to be equal, right? Perhaps we want to still be able to compare them, and maybe we want to say, well, if the last names are equal, let's go ahead and sort by the first name. Last name first, and then by first name. So we can do that. And in this case, we need to use a conditional. So here we can say if this dot last name dot compare to other dot last name is 0. So this means the last names are the same, they're equal. Then we can just return this dot first name dot compare to other dot first name. But otherwise, and this means the last names are different, then we just go ahead and compare by last name. Just like before. So this will allow us to compare by two different characteristics. So if we run our tester, you'll see that we've got Greg Graduate comes first and Greta comes second, because Greg alphabetically comes before Greta. Okay. Now, some people find this setup a little bit flipped as to logically how we think about it. This is how I tend to think about it, but it would be just as valid to say if this dot last name dot compared to other dot last name is not equal to 0, meaning again they're different, then just return that comparison. And otherwise, return the first name comparison. So this makes more logical sense to some people. It's the same, you're doing the same thing. It's just if one way makes more sense to you, then go ahead and use that way. Use whichever way you think is more logical. Okay, so this is the same idea. And of course, there is a little bit of a efficiency improvement that we could have here. We are calculating this dot compared to last name twice. So we could always store that in a local variable. So I could say int last name comparison equals this dot last name dot compare to other dot last name. This will allow us to reduce that bit of repeated code. And then I can say, okay, well, if the last name comparison is 0, then I want to go ahead and return the first name comparison, which is this dot first name compared to other dot first name. And otherwise, if it's not, I just want to return whatever it is. Okay. So there are a couple different ways there to implement the same code, comparing by last name and first name. All of these will have the same effect in terms of sorting, just a couple different ways to write it. This one, is nice because it has that little efficiency that reduces the repeated code. I wouldn't say efficiency is probably not going to really change the efficiency of the code, but it does reduce duplicated code, which is always a good thing, or repeated code, which is always a good thing. But a couple different ways to do that, and again, all of them are correct. I recommend just going with whatever logically makes sense to you. Now, one last thing we can look at is, okay, so what if we have two students with the same name, right? That happens a lot. So we have, let's say we have two UMA Uncertains. Of course, they're going to have different IDs, but they have the same name. Well, our current comparison method does not tell us what to do about that. It'll just return these two students. If you invoke compare to on these two students, it'll return 0 because the last names match and the first names match. But we know that these aren't equal students, right? We want one to be considered greater than or less than the other. So perhaps we want to say, first compare by last name, then compare by first name, and if those two things match, then go ahead and compare by ID. So let's write one final version of our compare to here. This is, what number are we up to here? Method 4? Nope, method 5. Okay, so this is going to be, we're going to compare by last name, then first name, then ID. I should probably call these approach 1 through 5 instead of method, or just doing different versions of the same method. So here I'm going to start off just like I did before, and I'll use that in last name comparison equals this dot last name dot compare to other dot last name. And I'll say, okay, if they're equal, then I want to compare the first names. And I'm going to say in first name comparison equals this dot first name dot compare to other dot first name. And then if that first names are equal, so if the first name comparison is 0, then I'm going to compare based on ID. And I'm going to use my integer dot compare for that. Now I've got to fill in my else's here. So this one is last and first names equal compare by ID. And my else here is going to be return my first name comparison. So this means last name equal different first names. And then I've also need an else here where I'll return my last name comparison. Okay, so now I can go ahead and sort again, and you'll see I sorted by last name, then first name, and then by ID. Okay. So there is an example of defining how to compare two objects and using that to then sort some objects. One final note I want to make is that if, let's say, we go with this last version we wrote where we're comparing by last name, first name, and then ID, note that this means that our equals method isn't consistent with compare to, right? So two students here, well, actually, the way we've written this with just looking at ID, it would be because we're assuming our IDs are always unique. But note that in general, if your equals method looks at different variables than your compare to method, that it's possible that those two methods won't be consistent with each other. That just because equals is true, it doesn't necessarily mean compare to returns 0 or vice versa. That's not very common to happen, but it can happen. Okay, so you can take a look at the comparable page for that. It talks a little bit about consistency with equals, and it gives an example of a class in the Java Standard Library where those two methods are not consistent. But just kind of keep that in mind that in general, unless there's a good reason to, we probably want the equals method and the compare to method to be consistent with each other, which means that if equals returns true, compare to should return 0 and vice versa. Now, again, in our class, if we are assuming that student IDs are always unique, then that is going to be true for us, right? Because if two students have the same ID, it's the same student, they'll also have the same, last name, first name, and ID, so those two methods will be consistent. But in other classes, it might not be so straightforward. So just something to keep in mind. And then one actual final thing I want to say is that the compare to method only allows you to define one natural ordering. You don't have the choice of saying, sometimes I want to order by ID and sometimes I want to order by name. There is a way to do that, and it's through a technique called a comparator. Not comparable, but a comparator. That's outside the scope of what we're going to look at in this video, but I want to mention it for those of you who want to look into it on your own. You can do so. You can look at the comparator interface in Java, and you can take a look at how you might use that. But just be aware that that is how you can create functionality of having different options of how to sort something. But comparable doesn't allow that. It only allows you to define one natural ordering, and that is the natural ordering that is then used by any sorting methods, including arrays.sort or collections.sort.